Good morning all. Today, and we've never done this before, I've never done this before, but we're going to convert this Lenze control board from servo drive board to positioning drive board. Oh, that's going to be a lot of fun to try. We can give it a go. If it works, it works. If it don't, it don't. Okay, we'll look at this program right here, and you'll see from the program we've downloaded the parameters off of this servo control board, and you'll see that this setup down here is for servo. This is how the Global Drive Easy program looks when we have a servo control board. You see down here, these windows are for the servo. In the positioning control board, if we're successful, we'll see positioning controls down here in these windows. Wish us luck. We'll see in a little bit. Now what you want to do is put the palm of your hand on top of these capacitors right here to hold the power base down, and then grab the control board and rock it straight up and off the power board. What we're doing is we're disconnecting this connector right here, these stake pins, from this connector right here. Here's the positioning board, and I already have the flash memory removed from these 2 points right here. But this positioning board does not power up. And so we're going to take the flash from this servo board off and install the 2 flash memory onto the servo board, and hopefully we'll have a new working positioning board. These 2 part number boards are 9321MP. 9321MP. This board and this board, they're laid out the same. Let me go get a 9324MP and I'll show you what the differences are. Now here's a 9324MP, and you can see the flash is laid out a little bit differently. Instead of side to side, it's straight up and down right there. I've already tried moving that positioning memory to a 9324MP. It does not like that. The drive does not boot all the way up. It continuously reboots. So don't try to put your 9321MP flash memory on a 9324MP. Don't make the mistake I did. That's me making the mistakes so you don't have to. Alright, now let's set this bad board that does not power up off to the side. We'll take this flash memory off the board and we'll install this flash memory on the board, then set that board back onto that power base and see what we get. I like to use this right here. This is called Chip Quick. And Chip Quick stays molten long enough to allow you to remove surface mount ICs. That's some good stuff right there. It's expensive, but it'll pay itself back. Add some flux. Okay, there's one. Let's get the other one. We've got both flash memory removed from the board. Now we'll clean up this area right here and install the positioning flash memory. Now we'll set an anchor point for both flash. Get my hat off so I don't get it in the way. I got a diagram that shows high bite right here, low bite right here. Now the flash, they're labeled high bite and low bite. And also put a little sticker on the back that says high and low so I don't get them mixed up. We'll do high bite first. Turn this way. Are we still in the frame? I think we are. I'll turn it that way so I can get to my anchor point a little bit easier. Okay, let's see if make sure we're lined up. Looks like we're lined up pretty good. Could probably go this way a little bit. Just a little bit. Let's call that. See what that looks like. I think that will do it. Some flux. This will help that solder flow a little bit easier. There's the high bite. Now for the low bite. Gotta go that way a little bit. That should do it. There we go. We'll clean up our work, install it on the power base, and we'll see what we get. If we're successful, we'll have a positioning control board. Make sure I get the pins lined up. Now we have positioning windows. So far so good. We're probably going to come up to an alarm though, because the drive has servo parameter sets. And we're a positioning drive now. We'll see what we get. There we go. PR0 trip. Parameter set error. Let's see if we can load in a positioning parameter set. Let's see. Read parameter sets from file. Let's try this one. Now let's save that parameter set. Go back up here, load positioning programs, let's see. Right parameter set to drive. save that to the drive. Now let's cycle power and see what we get. There you go. SD2 trip is resolver fault. Because we don't have a resolver connected to that drive, we get that SD2 trip. But we have a good positioning drive now. Let's test our Lenze positioning drive. The light bulb bank will simulate the motor. It's connected to UV and W. This knitting machine motor, its resolver is connected to X7. I'm going to rotate the resolver and we'll watch the light bulb sequence. Let's enable the drive. There we go. Let's rotate the resolver. That is perfect. Now if I go too far, we'll get a PO2 QSP alarm. That's because I'm going against the positioning program by rotating this by hand, rotating the resolver by hand. But that looks real good. We'll stop right there before we get that alarm. It works! All right, good job, folks. That was a grizzly bear. I didn't know if we were going to be successful, but you did it. You did it. Good job. Let's power down. We'll put the covers on.